Hi, teacher. Uh, Today I am going to talk about the project number 1. Uh, our team are Anderson Remache, Jose Núñez, Cristian Reyes, and Diego Narváez. For this project, we select a simple rigid body and an iPad box. We chose it because it has a rectangular shape and 3 different dimensions: length, width, and thickness. Therefore, it has 3 different moments of inertia with respect to its principal axis. According to our dynamics class, the moment of inertia represents the resistance of a body to rotational acceleration. The objective of this project is to calculate the 3 principal moments of inertia and identify the axis around which the body rotates in unstable way.
Okay, the measured dimensions of the iPad box were x equal 26 centimeters, y equals 19 centimeters, z equals 5 centimeters, and the mass was 286 grams. In SI units, these values are x equals 0.26 meters, y equals 0.19 meters, z equals 0.05 meters, and m equals 0.286 kilograms. Using the formulas for a rectangular prism, we obtain I sub x equal 9.20 times 10 to the minus 4 kilograms meter squared. I sub y equals 1.67 times 10 to the minus 3 kilograms meter squared. And I sub z equal 2.47 times 10 to the minus 3 kilograms meter squared. So the order is I sub x is less than I sub y is less than I sub z. And now, here are the calculations.
This happens because of the intermediate axis theorem. In class, we learned that when a rigid body has 3 different principal moments of inertia, rotation around the axis with the intermediate moment of inertia is unstable. A small disturbance during the motion grows and makes the body flip. The Earth rotates around an unstable principal axis because its rotation axis is approximately aligned with one of its principal axes, not with an unstable intermediate axis. Also, the Earth is slightly flatter at the poles and wider at the equator, which makes its rotation around the polar axis stable.
Since Iy is between Ix and Ic, Iy is the intermediate moment of inertia. This means that the unstable axis is the y-axis, which corresponds to the width of the box. For the experimental part, we launched the box around its 3 principal axes, around the x-axis and the z-axis. The rotation was relatively stable. However, when the box rotated around the y-axis, it changed its orientation and tended to flip. This demonstrates the instability around the intermediate.
In conclusion, the iPad box allows us to calculate 3 different principal moments of inertia and experimentally demonstrate that rotation around the intermediate axis is unstable.